Hi everyone, welcome back to another video. So in this video, going through and talking about data. If we go back to the Asuro manual, on page 64, it starts to talk about pointers and vectors. Don't worry too much about that. As you can see here, it mentions int line data 2 and int odometry data 2. So this is basically just declaring a variable array, and it's going to store two values in that array, constantly be updated in real time by the user. So this line data variable here, it will store the values given to it by the left phototransistor and the right phototransistor. So we can use the data stored in the arrays to get Asuro to act whether or not it's on the line or not on the line, etc. We'll get started with the front infrared receivers. If you take a look at this graphic, this is basically how we decide whether we're looking at a line or we're looking at a surface. So if the infrared emitter beams a light onto the surface and the detector doesn't receive any light back or very little light back, we know that it's on a black surface. If the infrared receiver does receive a lot of light back, then we know that it's looking at a white surface. What we'll do is, let's get started with writing our program to detect the line. What we're basically going to do is, the logic for our program is going to be, we're going to turn on the front LEDs, right? LED, just put the line follow in. Then we're going to read the data received by the two photo transistors, right? I before E except after C. Cool. Then what we're going to do is we're going to compare the data received to a midway value. So I'll explain what that means. What I mean by midway value. The midway value is halfway between black and white. What that means is that when one way to look at it is that when we're receiving the line data back from the phototransistor, or when we're receiving the line data back, it gets stored into a variable to that array, which is here, the int data. It gets stored as a number. So when that gets stored as a number, that number is somewhere between 0 and 2000. This number represents how much light is received by the phototransistor. 1500 plus is pure white and 0 is pure black. Obviously, because there's no light received if it's a black surface, and if it's pure white, then pretty much all the light is received back, right? So obviously your ambient light will affect things as well. So the midway point is roughly 800 to 1000. We'll probably go for 800 on yeah. Let's say midway value 800. Cool. Okay. So what we're going to do is we're going to compare the data to achieve to a midway value, and then we're going to say if under 800, then status LED, let's do green. So what that means that if it's under 800, it's detecting a black line and it'll go green. And if over 800, then status LED red, right? So think about 1500, 1600, 2000 is pure white, 0, 100, 200, 300 is pretty much pure black. So if it's under 800, more than likely you're on a black surface, so go green, because green being positive, we want the 0 to follow the line. And if we're not, then go red if we're above 800, meaning that we're on a light gray white surface. Cool. Okay. So this should be fairly easy to code. The only part that we need to concentrate on really is the reading of the data, which I'll talk through to get there. First, let's just write our include 0.h int main void, right? Brackets, put our return 0. Put our whole program in a while loop. Always like to do that. Okay. Let's initialize our microcontroller before we go into. Okay, so we're gonna turn our front LEDs on. Front LED, right? Then we're gonna make a variable for our front LED. That's gonna do an unsigned int variable. I'm gonna call it iData. and we're going to make it an array with 2 elements. If you don't know what this is, I'd suggest practicing some C programming. It's very not too important, but it is important you understand variables and arrays. You know how we store information in those variables in those arrays. Okay, so then let's make another while loop. One. What I just want to explain quickly is that so the program's going to run this the whole time, right? So the front LED is going to be constantly turned on, meaning just be kept on, and it's going to got a variable here for our data. And then what I'm going to do is I'm going to call a lineData function. This lineData function is exactly the same as the motor direction, motor speed functions. Remember, it's getting it from here. We're calling this function lineData from the Asuro header file. And what we're doing is we're saying to this function returns 2 values to us. It returns the left phototransistor value and it returns the right phototransistor value. We're saying store the information that you're sending over to us, store it in this array here, right? And we're going to access this array. For you, we want you to store it in there. Okay, so now that we're storing the data into the variable, what we're going to do is we're going to test that variable, and we're going to test each element of the array, each variable in each element, and we're going to say, are you greater than or less than 800? Cool. So the way that we do that is obviously if statements, conditional, and then we're going to say if. We're going to use 2 if statement, 2 brackets. I'll show you why, because we're going to say if I data, and we're going to say element 1, meaning the first element. In this instance, the first starts at 0, right? So element 0 is less than 800. Okay. Then we're going to say and, because remember we've got this would be the left phototransistor. Now what we're saying is if the right phototransistor as well is array position 1 is less than 800, both in brackets. So think about this condition, right? What we're saying is if the left phototransistor and the right phototransistor, both of them together, are less than 800, then we know that we're on black. So we're going to say status LED, we're going to go green, right? Then we're going to say otherwise, if you're both greater than 800, we're going to make status LED red. So since we're just doing a general otherwise, if it's not less than, we can else, right? And then we can just say status LED red. That's that. Let's go through the logic again, right? So we wanted to turn on the front LED, which is what we've done. Then we want to read the data from by the 2 phototransistors, which is what we're doing here. We're storing it in this variable here. Then we're going to compare that data to the midway value. So we're saying, okay, how do you compare to 800? Are you less than or greater than? If you're less than, then turn the status LED green. Greater than, turn the status LED red. End the program. That's it. Yeah, cool. So let's have a look at how that looks. As you can see, it clearly detects the difference between the black line and the white surface. So that's it for this one. In the next video, we'll start to actually get the Asuro moving towards the line. From here, you should be able to do it all yourself. You have all of the skills you need now to be able to get the Asuro to follow the line. It's just about applying the logic to it. So we'll discuss the logic in the next video, and we'll write some code and we'll get the Asuro to follow the line properly. Cool, guys. All right, we'll see you in the next one. Peace.